So normally we will call this parabola fit. This comes under non-linear regression. Actually we have done linear regression. Why we are saying that one is linear regression? We are fitting straight line in that case. Okay, straight line means it is linear, since each and every degree value of each and every variable is equal to 1. So the straight line equation is a linear one. That's why that fitting also called straight line fit, linear regression. Here it is called non-linear regression, since we are going to fit a parabola or any curve, but particularly in this case we are going to fit a parabola in non-linear regression. You see, depending on the given data, depending on the given data points, depending on the plotted graph of given data, you can understand why we need parabola fit. You see, suppose if we are given the data points like this, you see, if you are having the data points like this, means you can fit a straight line. Okay, you can fit a straight line. You can get a most approximate straight line fit for those given data. Best solution you can get, you can reach. But if you are given the data like this, plotted points, if you are given this kind of data, if you find a straight line fit, already it is there. If you find a straight line fit, so you cannot get a best solution, you cannot find the best approximation for those data if you are finding straight line fit. Okay, you see, there is error, right? Maximum error is there, error value is high, error value is high. So for this kind of data, if we can find a parabola fit, if we can find a parabola fit, curvy fit, it will be useful. So you can find a better solution, you can find a better approximation. Okay, that's why we need parabola fit. So depending on the given data points, we are going to use either straight line fit or parabola fit. Okay, so now you can understand why we are using parabola fit. If we have data points like parabola, okay, if we are having data points like best approximation like a parabola fit, then we are going to use parabola fit, non-linear regression. So what we are going to find in this, we are going to fit a parabola. Normally we can write general form. Normally we can write the general form of a parabola. Y is equal to a plus bx plus cx square. Of course you will write in the form of y minus a the whole square is equal to y minus a the whole square is equal to 4a into x minus b the whole square. So in this way you will write a parabola. So in this way also you can represent that parabola. Y is equal to a plus bx plus cx square. So you are going to find a parabola equation. In that, what is our aim in this statistics? What is our aim is going to be? Our aim is going to find A, B and C. Okay, there what we have to fit in the previous method, what we have to fit in the previous method, we have to fit a straight line, which means a plus bx, which is straight line fit. Okay, so in that case what we need to find a value and b value. By using normal equations we found the value of a and b. Here additionally we are having only one term, right? You can compare this. Additionally we need only one term, which is cx square. Okay, now you can understand. Additionally you have to write cx square, which means non-linear term. So additionally we have to find c also. So find a, b, c. So we need normal equations like we did in straight line fit. We need normal equations to find those a, b and c. So what are the normal equations? No need the things, no need to mug up everything. I will tell you how to write this normal equation also. It is very simple to write normal equation. So how to write? You listen here. So I am going to fit a parabola y is equal to a plus bx plus c x square. Okay. First you take summation on both sides, summation y, summation a plus summation bx plus summation cx square. Okay. In this you take out all the constant value. Here constant value is a, but how many times it is, this constant is there, how many times, if we are having n number of values, n times a, so normally you can write n times a plus you can take out b here, you can take out c here. So this is one normal equation. Then how to find the second normal equation? We need three normal equations to find a comma b comma c. Then only we will be in a situation, three variables, three equations with three unknowns. Okay, we will be in a situation three equations with three unknown. Now to find a normal equation, second normal equation, what we have to do? We have to multiply by x throughout all the terms. Multiply by x. What you will get? X summation xy. Summation xy. Here first time a variable is involving. So a into summation x. No need to write n here. Why? Because this x is n times x. Okay. Normally n will be there. N times x. So you will get a and x. That's why here no need to write n here. No need to write n separately. Plus b into, we are multiplying by x square plus c into summation x cube. So this is second normal equation. Then third normal equation, again you multiply by x. Actually this is shortcut, this is not the original procedure. Again you multiply by x summation x square y, a into summation x square plus b into summation x cube plus c into summation x power 4. Okay, here actually x cube. Okay, it has been deleted. So cx power 4. Cx power 4. So what and all the values we need? This is called a normal equation. These equations we are going to use to find the values of a comma b comma c. So what and all the values we need from the table? I need summation y, summation x, summation x square, summation xy, summation x already is there, summation x square already it is over, summation x cube and summation x power 4, this value also. So I need how many values? 1, 2, 3, 4, 5, 6. 6 number of values I need to find the a comma b and c to fit a parabola for the given data. So you look at here, you can understand. So these are all the normal equations that I have explained just now. I have explained. So these are the normal equations. Just now I explained how to write those normal equations from parabola equation. So this is explained. Okay, and it is written. It is in the written form. Now I will explain one example. Find least square polynomial approximation of degree 2 to the data. Okay, so they are asking to fit a parabola for the given data. Find a parabolic equation for the given data. So you know what is the parabola equation? Y is equal to a plus bx plus cx square. What is our aim? Our aim is to find a, b and c. Our aim is to find a comma b comma c. So to use the normal equations, I told you already, I explained to you, I need 6 number of values. Okay, summation x square, summation x square y, summation x cube. So I am going to find all those values from the table. So for that I am framing a table. In the first column I am keeping x, second column I am keeping y. These are all the two values. It is already given to you. Then xy, you know how to find xy. xy means corresponding x to 0 into minus 4 0, 1 into minus 1 minus 1, 2 into 4 8. So in this way you calculate by using calculator xy. Then addition of all these values, summation xy. Addition of all these value, summation xy. Then I need square. X square means the value of x the whole square. So 0 square, 1 square. So in this way you can find x square. You find the summation of all these row x square value. So I am getting summation x square is 30. Then x square into y, mixed term, x square into y, which means x square into y. So 0 square into corresponding y is minus 4. So I am getting 0 here. 1 square into corresponding y is minus 1. So what I am getting minus 1. So in this way you find x square y. So summation x square y I am getting 434, x cube x power 4. So in the similar way you can find, okay, x cube, you know, by using calculator it is easy, and you can complete within a limited period of time. You can complete all the calculation if you are using calculator. So please use calculator to find all these values. So x cube, find the x cube value for each and every x is given to you, and x power 4, find x power 4 for all values, value of x which is given to you. Then add all those values to find the summation x cube and summation x power 4. Okay. Now I am going to use all these values. I told you 6 number of value, 1, 2, 3, 4, 5, 6 number of values I am going to use. I am not going to use this, I think. So no need of summation y. So now we will use all these values in this. Actually we need summation y also. So by using all these values I am going to find a comma b comma c. I am going to substitute all these values in normal equations to find those a, b and c. So you know the normal equations from the table. I know summation y, n is number of values. What is n here? Number of values is 5, n is 5. Then summation x from the table, summation x square from the table, summation xy from the table, summation x square from the table, summation x cube. So you can substitute all the values that we already found from the table. Then you will get 3 equations. Then you will get 3 equations, 3 normal equations with 3 unknown. What are all the unknown values? A, B and C. Okay, what are all the unknown? That is our aim. Our aim is to find those A comma B and C. Okay, so here we are having 3 equations with 3 unknown. Then we know we can find the values, the unknown values by direct method, elimination method. We are having many methods to find those A, B, C, and especially you can use calculator. Okay, it is better to reduce the time consuming, okay, time duration to complete the problem. It is better to use calculator. So use calculator and this a comma b and c value, then directly you can find a is equal to minus 4, b is equal to 2 and c equal to 1. Okay, so 99% of the problem over. Now what is the remaining? Substitute all these value in the parabola equation, our assumed parabola equation. What is the parabola equation? Y is equal to a plus bx plus cx square. Now you substitute all these values, what you will get? Minus 4 plus 2x plus x square. Okay, so in this way you can fit a parabola for the given data. Now look at one more example to fit a parabola. Actually here we are going to change this scale, we are going to change the origin. Actually we did one problem in straight line fit also by changing the scale. Why? Because we are changing the scale to reduce the calculation part, or to reduce the time duration to complete the problem, we are changing the scale of the problem, of the given problem. We are going to change the scale, okay, so that we can compute the value in a easy way. We can deal small number, okay, no need to deal with a large number. We can deal with small number and we can calculate in a easy way, so that we are using change of scale. So you see here, y value is 124, 129, 140, so it is somewhat big values. If you find the square for these values, x square, y square, so you will get a larger value, okay, you will get somewhat high values, so the calculation will be somewhat tough, okay, it will take time also. That is the reason why we are changing the scale of original problem. So when we are changing the scale, our parabola equation itself will change, right? Our parabola equation itself will change. Normally our parabola equation is y is equal to a plus bx plus cx square, okay, but here we will use, instead of x we will use u, instead of y we will use v. So v is equal to a plus bu plus cu square, okay. This is the parabola that I am going to fit. This is the parabola that I am going to fit. Okay, this is my required parabola. This is my required parabola. In this, what I want to find? A, B and C. Okay. So, but I have to assume the relationship between u and x, v and y. By looking at the data, I have to fix the relationship between u and x, v and y. So how I am going to fix the relationship, I will explain, and before that I will give you the normal equations. In terms of x and y, you know how to write normal equations. Similarly, write the normal equations in terms of v. You just replace x by u and y by v, so that you can get all these normal equations in terms of u and v. So now I am going to fix the relationship between u and x first. First, what is the relation? What I am going to assume u, so that I can reduce the calculation numbers, okay, calculation number, I can reduce those values. So u is equal to something x minus what value I am going to write. You look at x, normally what you will do, to change the origin, we will take the average value, okay, then we will select that average value. If it is available exactly, we will take that value. If it is available, if it is not available, take the nearest value. Here average, definitely you can understand, or you find also. I am going to assume this 6, so that 6, like deviation, okay, like deviation we are writing now, u is equal to x minus 6, u is equal to x minus 6, and v, what I am going to fix, look at the y value, find the average, okay, then you select the nearest value. So you select the nearest value, you find the average. I think the value which is near to 289, that's why I am going to assume v is equal to y minus 289, okay. The value is near to, you will get the value is near to 289, average of y. That's why I am going to fix v is equal to, now I am going to fix the relationship between u and x. I am going to write u in terms of x. I am going to reduce the scale, I am going to reduce the values, okay, I am going to reduce the values. For that I am going to change the scale. So u is equal to x minus what value I am going to write, what you have to take the average value, you got to find value of x, and if that average value is in this x, you have to select that point. Not available, you average value. So normally here definitely you will get 6. Okay, you will get 6. So I am assuming u is equal to x minus 6 and v is equal to y minus what value I am going to write. You find the average value, you find the average value of y, you will get some value, that's 228. It's your wish, you can assume 289 also. Okay, if you are assuming in a correct way, you will get better solution. Okay, you will get solution, you will get a parabola. But if you are assuming in a correct way, if you are assuming somewhat exact value, then you get better approximation parabola curve. So what I am going to assume, 228. Okay, v is equal to y minus 228. So you add additional column to find u and v. You add additional column, you see u is equal to x minus 6, u is equal to x minus 6 and v is equal to y minus 228. So you find all the u value, you know how to find corresponding x minus fixed 6, okay, 2 minus 6 minus 4, 3 minus 4 minus 6. So in this way you can find u. Similarly you can find v. Then no need to find summation x, summation y square, all those values, because we are going to use the values in u and v, the values in u and v. Okay, so you find uv, you find u square. So what are all the values available in normal equations? U square v, u cube and u power 4. Okay, you find all the values, you know how to find, multiply u and v correspondingly, find particular u, find u square. So in this way you can calculate all the values, you add all the column values so that you can get summation uv, summation u square v, that's all. Then you substitute all these values in normal equations. You substitute all these values in normal, these are all the normal equations. Already I have explained how to write these normal equations. Okay, you substitute all the values, summation v, n is 10 since we are having 10 values, summation u is minus 5. So you substitute all the values that you have found from the table. Okay, then you know how to solve. Actually here it is solved by your previous well-known method, but you can solve by using calculator. So you solve all these equations. Since we are having 3 equations with 3 unknown, you can solve by using calculator all these 3 equations, then you can find the values. Actually what I am getting, C minus 13 by 3, then B you will get 2336 by 165, then C value already we found, then A value you can find also 5249 divided by 165. So these are all directly you can find, no need of these steps, directly you can find. You try to reduce the time duration to complete the problem. That's why we are using change of scale also. So you have to reduce the time duration whenever you are doing the problems in statistics, because you will be in a situation to solve many problems. You have to use calculator in a fast way. Okay, so I found the values of A, B and C, then substitute those A, B and C in that parabola equation. B is equal to A plus BU plus CU square. But this is not the final parabola. Actually for our convenient we have written that parabola fit in terms of u and v. Now I need in terms of x and y. Since the data is given in terms of x and y, I have to write the parabola fit also in terms of x and y. But I know the relationship between u and x, v and y. Okay, already I have written you know u is equal to x, v is equal to y minus 228. You can substitute all those values, you can substitute all values, then you will get a parabola equations like this. Y is equal to some a plus bx plus cx square. Okay, so this is my required parabola fit for the given data. So this is my required parabola fit for the given data. So you can practice these problems. First one, in the first problem, no need of changing the scale, no need to change the origin also. You can find directly the parabola fit. In second question also it is easy. The data are having very smaller number, so no need to change the origin. So you can fit the parabola for this given data. You note down these problems. So thank you so much. If you are having any doubt on this, you can call me or you can mail me to this mail ID.